In this example, we have a water heater that is the shape of a right cylindrical tank. So you can see I've drawn our hot water heater over here on the left side of the slide. And we know that this tank has a radius of 1 foot. So let's go ahead and label that information on our tank over here. We're also told that it has a height of 4 foot or 4 feet. So let's go ahead and label that information. Now the question is, how fast is the water draining out of the tank? Well, that to me sounds like they're asking for a rate. If we're being asked for a rate, we're going to need a rate equation. But we know by now that rate equations don't start as rate equations. They start as regular formulas. And then we differentiate them with respect to time to make them rate equations. And notice here that we're given our units for how fast the water is draining out of the tank. It says that we want these in cubic feet per minute. Well, cubic feet per minute, that's a volume measurement. So we're technically being asked for the rate of change of the volume, and we're given the radius of the tank, and we're given the height of the tank. So we need a formula that relates the volume of water in the tank to the radius and the height of the tank. And that formula is the formula for the volume of a cylinder. Volume equals pi times radius squared times height. Now we can go ahead and plug in 1 for the radius here. And that'll give us volume equals pi times h. And we can do that because the radius of the tank is unchanging. No matter how much water is in the tank at any given time, the radius of the tank is still going to be 1 foot. Now, we can't plug in 4 feet for the height. Why? Because the question that we're being asked is, how fast is the water draining out of the tank? Well, if the water is draining out of the tank, then the height of the water will be changing. So the height here is not just the height of the tank. It's the height of the water, because it's the height of the water that gives us the volume of water inside the tank. So the height is a changing value. It's not constant. Therefore, we can't just plug in 4 for the height. So our volume formula is pi times h. And remember, pi is a constant. Now this is a static formula. This formula will give me the volume of water in the tank if I know how high the water level is. But we need to change this into a rate of change equation, not just a static equation. How do we do that? We differentiate both sides with respect to time. Differentiating v with respect to time gives us dv over dt. The derivative of pi h is pi. But because we're differentiating with respect to time, not with respect to h, we have to multiply that by dh over dt. And now this is our rate of change equation. And we want to know how fast the water is draining out of the tank in cubic feet per minute. So another way of saying that is we want to know what dv over dt is. We want to know how the volume is changing with respect to time. Now before we move any further, we need to recognize something. Our volume units are in cubic feet per minute. And these pi units over here, well, remember that pi was multiplied by r squared. Our r was given to us in feet. So that means r squared would be in square feet. What units is our dh over dt? dh over dt is given to us in inches per minute. Well, if we want this equation to play nicely, we need to be in the same units across the board, because dv over dt is given to us, or it's being asked of us, in cubic feet per minute. And because our pi units are in feet squared units, then I think we need to go ahead and change dh over dt into feet per minute rather than inches per minute. So what is dh over dt in feet per minute? 6 inches is half a foot. So that means that dh over dt is half a foot per minute. So we would have dv over dt is equal to pi times negative 1/2. Now you look at that and say, well, where's the negative come into play? The negative just tells us in which direction the water level is going. If it were rising, the 1/2 would be positive because it would be increasing. But in this case, the water level is dropping. So we have a minus 1/2 because the water level is dropping at 1/2 foot per minute. So that means that dV over dt is equal to negative pi over 2. And our units are cubic feet per minute.